Developing Sites for the Web. About this course. Welcome to the Developing Sites for the Web course. In this course, you'll learn how web developers create websites. You will learn about common web development languages including HTML, CSS, and JavaScript, and how they have evolved. You will also learn about the software development lifecycle and ways that an agile approach improves web development. Learning objectives. After completing this course, you should be able to identify the purpose of web browsers, describe markup languages and the challenges they can overcome, explain the structure, functions, and evolution of HTML, identify improvements that HTML5 introduced, explain the features and functions of CSS, explain the features and functions of JavaScript, identify the ways JavaScript interacts with CSS and HTML, identify phases in the software development lifecycle, SDLC, differentiate between waterfall and agile approaches to development, highlight the Scrum framework. About this module. Module 1. Web browsers and markup. Introduction. In this module, you will explore web developers' role in creating the experiences that bring the Internet to life. You'll learn about the development of web content and how that content is presented to users, which is mainly through web browsers. You'll learn about the challenges of transmitting data over the Internet and how markup helps developers address those challenges. You'll also learn what web developers need to consider to make the web a great experience for everyone. Learning objectives. After completing this module, you should be able to describe what a web browser does, identify challenges of transmitting content over the Internet that markup helps address, describe the relationship between web browsers and markup, identify factors web developers consider when working with different browsers. What web browsers do. The Internet has abundant resources and information for everyone to access. The most common way of interacting with these resources and information is through a web browser. A web browser enables users to view and exchange information with websites. Many different web browsers are available. Some of the most common are Microsoft Edge, Mozilla Firefox, Google Chrome, and Safari. To understand how a web browser displays information to users, consider a paint by numbers activity. The numbers on the picture tell the painter what color to use and where. In this example, 1 is yellow, and 4 is green. When people see the final painting, they see a colored picture of an apple, not the numbers or instructions the painter followed. Similarly, a web browser displaying content such as headings, paragraphs, images, and links needs instructions to format the information. But for web browsers to do this, they need instructions in a language they understand. The language web developers use to write these instructions is called markup. Markup wraps the website content with instructions that describe to browsers how to display the information. For example, in the following markup, the brackets and letters outside the phrase instruct a web browser to bold the phrase "Developing for the web is fun." Developing for the web is fun. The web browser displays, or renders, the information. Rendering is when the browser interprets the markup to format the content and display to users. The previous example would look like this in a web browser. Developing for the web is fun. As Internet technology developed, so did the ability to process documents containing markup. Over time, web developers created a detailed markup language for web content called Hypertext Markup Language, HTML. Web browsers process HTML documents and display the content to users. Here's another example of some simple HTML code that describes an unordered list, which is a list that uses bullet points. This is how the HTML markup appears in the HTML document, with defining an unordered list and defining a list item. Item 1, Item 2, Item 3. When rendered, the web browser interprets the HTML and displays the content as a bullet list. Item 1. Item 2. Item 3. The following screen capture shows an example of the HTML code for the IBM Cloud web page. Check it out. You can view the HTML code for a web page by navigating to a website you visit frequently. Once at the site, right-click on a blank space on the web page and select Inspect from the menu. What do you think? Browsers interpret markup and show users the result. You might be wondering why web developers use markup. Why don't they just send a fully formatted document rather than using markup that the browser has to interpret? Enter your response in the provided text box. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? Documents containing lots of formatting and text can become large and require all users to use the same application to create and view the document. These conditions can create problems when users want to work together. Web developers working on early versions of the Internet anticipated these problems and thought there was a better way to do things. You'll learn about some of these in the next lesson. Web browsers and markup address the challenges. Imagine you have the paint by numbers Apple picture, but it doesn't have the numbers, it doesn't list colors, and it doesn't even include the instructions. You might be able to figure out how to color it, but when you're finished, the Apple picture probably won't look exactly like the original. For art, variation is encouraged. However, with web browsers, you want everything to appear as intended. Markup has the instructions for web browsers, so everything appears as it should. What are the challenges that web browsers and markup addressed? One of the challenges is embedding, which is when information is included within a document. Embedding can be a challenge because a document with many files included in it can become too large. This leads to an additional challenge, which is document size. Larger documents delivered through the Internet require more resources from the network, which means that if a document is too large, a web browser might not be able to display it, or it might take a long time for the page to load. Another major challenge for web browsers is openness. Applications written in code that a browser can't read mean that others who try to access the application can't read the document either. Web developers have solved some of these challenges by using markup languages like HTML to provide instructions on how to display content in browsers properly, to reduce file sizes, and use less bandwidth to send and receive documents. The Internet has become a powerful tool with capabilities beyond what its early developers ever dreamed of. Even so, the servers that power the modern Internet require energy, bandwidth, and processing power. Making efficient use of those resources is not only smart, but also responsible. This means that many of the original design goals that early web developers pursued are still valid. Consider this scenario. Suppose you are finishing a report for a course assignment. You've used a word processor application to write it, using regular, bold, and italicized text and other formatted items. You've also included images in the document to illustrate your points. When you try to email your document to a friend to review, your email provider alerts you that your file is over 50 megabytes, MB, and that it won't send files larger than 30 MB. After some troubleshooting, you figure out how to email your full report. But soon after sending your email, your friend responds that they cannot open your report because they don't have that word processing application. What you've encountered are some common challenges that occur when transmitting content between users. Embedding. Because your document contains additional files like images, other documents, and diagrams, it stores all that information in the document file. Your word processor embeds the information directly in the file. For example, a page displaying an image includes the data that makes up that image inside the document file. Sending your document to 5 friends requires your email provider to send 5 copies of the document with 5 copies of the image that is embedded in the document. Markup addresses this challenge by linking to files in another location rather than embedding them in a document. Size. Sharing large files over the Internet requires significant bandwidth. Bandwidth is the amount of data the network can transmit in a given period and is limited by the physical capabilities of the network. Like any limited resource, the more data that is moving over a network, the slower it becomes. Your email provider needs to ensure a great experience for everyone, so it limits your bandwidth to avoid impacting others. Markup addresses this challenge by being text-based, which requires less bandwidth. Openness. Because your friend doesn't have the same word processor application that you have, they can't view your document. The structure of document information is dependent on a specific or proprietary application. A proprietary application is an application whose code is closed to anyone except the company or individual that wrote it. Because of this, only people who own the proprietary application can access the document. Markup addresses this challenge by being open code that everyone can use. Developers who worked on early versions of the markup that became HTML were aware of these problems and came up with a way of sharing information that addresses the challenges. Markup is text-based. Unformatted text is lightweight and can be sent more quickly over a network. Text-based markup tends to use less bandwidth than other types of data. Markup links to resources. As a developer, you can include images in your HTML, but you can do this by linking to them in another location rather than embedding them in your document. This reduces the size of the document and thus the bandwidth needed to transmit it. Markup is open. Because markup is text-based, any application that can interpret HTML and display the results can render markup. In addition, markup is open for everyone to learn and use. For markup to be useful, it needs a browser to display it. When you send an HTML document over the internet, the browser interprets the text and handles all the rendering of the information in the document. Explore more. The Web Hypertext Application Technology Working Group opens in a new tab, creates and updates HTML standards, opens in a new tab. These are the technical specifications and guidelines to properly write HTML that are open and available to everyone. Take a moment to bookmark them now. The web browser experience. In the early days of browser development, some browsers didn't follow standards, so web developers had to write web content to accommodate all the varieties of markup that browsers expected. Today, companies closely align to accepted standards, so web developers can focus on writing good code. Web browsers come in various forms, from those running on laptops and desktops to those running on mobile devices. Because web developers write the code that tells browsers how to render a web page, they must ensure they have created a great user experience across all browsers. How is the content experienced? While this isn't strictly a browser consideration, how a page looks on different screen sizes and device styles can significantly impact the user experience. Web developers need to make sure the same web page looks good and is usable on small and large screens. How is data stored? Browsers on some devices handle data differently than others. For example, a browser on a desktop computer might have more capacity to store data and have different access to the device's storage than a browser on a mobile device. Web developers need to be aware of how much data needs to be stored and how different devices might store that data. What capabilities are available? Browsers on some mobile devices don't have all the features and functionalities found on desktop and laptop browsers. In addition, some browser developers might not have implemented all the features in the HTML specification. Web developers need to take these points into account when creating web pages. Web developers can't provide the same experience on every platform, but they should work to enable the same features for every user. They need to consider how users will access the content, how user devices will store the data, and what browser capabilities are available. About this module. Module 2. HTML, the language of the web. Introduction. In this module, you will learn about key developments in the history and development of HTML, the language of the web. You'll learn about the structure of HTML including tags, attributes, and schema. And you'll explore how these elements come together to achieve the presentation function of HTML. Learning objectives. After completing this module, you should be able to describe key developments in the history of HTML. Identify the structure of HTML documents. Explain the presentation function of HTML. History of HTML. When you learn to speak or write a language, you also learn a little about how the language developed. You might learn that the main reason the language developed was so people would be able to communicate, address specific needs, or solve specific problems. When you understand why a language was developed, you understand how to use it better. Spoken human languages have developed over thousands of years, but computer markup languages have existed for less than 100 years. Similarly to how human languages have developed, markup languages like HTML were developed by building on other, earlier computer languages. Review the following to get an overview of the history of HTML. The beginning, GML. Towards the end of the 1960s, 3 engineers at IBM developed a schema, an outline, for marking up documents. They mainly used this markup schema to describe a document's structure for IBM's script markup language. The engineers called the schema Generalized Markup Language, GML. The schema defined an opening tag, for example, H1 is the tag for a top-level header, but it didn't have a closing tag. It used a colon and a period as wrappers for the tag name. Even so, you can see a shadow of HTML in GML. Here's an example of valid GML. Notice that no closing tags are required. H1. This is a header. P. This is a paragraph. OLLI item 1 LI item 2 EOL. A step forward, SGML. One of the IBM engineers, Charles Goldfarb, developed a schema called Standardized Generalized Markup Language, SGML. The SGML specification called for angle brackets and tag names, and it described how to nest tags. Unlike HTML documents, SGML documents didn't require the use of closing tags. Developers were able to use symbols other than angle brackets to enclose instruction names. In this sense, SGML was more permissive than HTML. Here's an example of valid SGML. Notice there are no closing tags required. Chapter title emphasized item. This is a link. Enter HTML. Tim Berners-Lee, the creator of the World Wide Web, developed HTML in 1989 for the web browser he was creating. He needed a markup language that presented information clearly in browsers. HTML was largely based on SGML but included a tagging structure for linking documents and assets. Here's an example of HTML. Notice there are closing tags. Hello HTML. Hello, world. Learn HTML document structure. Natural languages have a grammar. Grammars describe how words or symbols should be formed, how words relate to one another, and how punctuation should be used. That is, grammars describe a language's structure. Similarly, programming languages have a structure. It's important to understand the document structure and the tag structure of HTML and how each part of the language works together. HTML describes a structure for the document as a whole and specific elements within the document. In the following sections, you'll explore elements of both aspects of this structure. Document structure. When a browser reads an HTML document, it looks for sections describing how to process the document. In English, sentences typically have a noun, a verb, and an object. Each of these elements performs a function in the sentence. Similarly, all HTML documents have sections that have a specific role in how the browser processes the information in the document. A properly structured HTML document includes each item in the following list. The HTML tag. The entire document is enclosed with the tag set. This is the root element of the page. The head section. Enclosed in the head element, this section contains resources that the rest of the document will use, such as scripts and style sheets. Most HTML documents also include metadata in the head section. Metadata is information about the document, such as the author and other relevant information that the user generally does not see. The body section. The body section contains all the primary content you see in your browser. Here's an example of what the structure looks like in an HTML document. A schema is the outline or structure of markup languages. A schema tells browsers how the content is organized. A schema also describes what is allowed or not allowed in a well-formed document. A document is well-formed when it adheres to the schema. An HTML schema might include head, title, body, and paragraph tags to tell browsers how the document is structured and how the document should be displayed. Hello HTML. Like human languages, many different markup languages have their own structures. HTML is one example. Another is the extensible markup language, XML, which is used mainly for data. XML markup is structured like HTML, but the schema is focused on data objects. Check your knowledge about what you just learned about document structure. Learn HTML tag structure. Within the document structure, there's an additional structure of tags. Tag structures have instructions enclosed in angle brackets. An opening tag and a closing tag make up an element. Most of the content of HTML documents is placed within elements. Angle brackets use the same characters as the less than symbols. Instruction names are words or letters. Examples of instruction names are strong, for emphasizing text, A, to create links. A stands for anchor, and I, to make text italic. Tags generally come in pairs for each browser command. For example, if you want to bold the word browser, you surround the word with the strong tag at the start and the end of the word. The strong tag around the word tells the browser to make the word browser bold like this, browser. The word browser is marked up with HTML in this example. Browser. Many elements have attributes. An attribute is additional data a tag might need to provide the browser with enough information to create the formatting or action the element requires, such as a strong attribute for font weight. The HTML specification also describes what attributes an element can support. Here are some ways to use attributes. Styles. A style attribute describes how the text, image, video, or other elements should appear. For example, text can be made to appear red by using style-related attributes. Developers also use styles to space items apart using margin and padding settings. Resources. Developers can use attributes to point to other resources. For example, an anchor element, which creates hyperlinks to other resources, includes the href attribute to identify the target file for the link. Here's an example. IBM homepage. This anchor element links to IBM's homepage. The href attribute tells the browser where to direct the user when they select the link. Events. Developers can also use attributes to respond to events. Many elements support the onClick event, which occurs when a user clicks the element. For example, if you create a button, you need to assign an action that happens when the user clicks the button. The click action is called an event in HTML. The onClick attribute enables the browser to know how to respond to the click event. Metadata. Developers can use attributes to add metadata to elements. For example, adding the attribute type equals button to an element tells the browser what kind of element to display. Web developers create HTML in the document structure using elements that have attributes. The content of the web page is placed within the elements. All of this is part of the grammar of the HTML language. What are the components of an HTML tag? The entire expression is called an element. The first is called the opening tag. The tag after the instruction is called the closing tag. The slash indicates the closing tag at the beginning of the browser command. Now that you have an overview of the structure of HTML and tags, check what you learned about attributes. Use HTML to present and format. HTML is a declarative language. A declarative language describes how to present or format the elements of a document, but not how to express or process those descriptions. For example, when you and a friend plan a meal, you ask your friend to make dessert. You don't care what the dessert is as long as it's sweet and delicious. You don't tell your friend how to do it. You only tell your friend to make the dessert. Like your dessert instruction, HTML tells a browser what to do but doesn't tell it how to do it. HTML uses the markup elements on a page to instruct the browser about what to display, but it doesn't specify how a browser should display it. But that doesn't give browsers the freedom to display content any way they want. Even though HTML doesn't specify how an element should be implemented, browsers still must follow the specifications. Here's an example of an element that typically italicizes text in a web browser. Web developer. This expression indicates that the computer should italicize the text web developer but does not contain a description of how it should be done. The HTML specification says this about the I element. The I element represents a span of text in an alternate voice or mood, or otherwise offset from the normal prose in a manner indicating a different quality of text, such as a taxonomic designation, a technical term, an idiomatic phrase from another language, transliteration, a thought, or a ship name in Western texts. Source: the HTML Living Standard. The I element opens in a new tab. November 2022. As this quote says, the I element should make the text it encloses offset or different from the text around it. Notice that it doesn't say anything about the text being in italics. Most browsers use the I element to make text appear italicized. An HTML parser, typically a part of a web browser, processes elements on a page. A parser is software that examines text in a document and separates elements. In this case, an HTML parser looks for HTML tags in a document and does the work of formatting text based on those tags. Can you name the term that matches the definition on the card? Presentation refers to how browsers format text and create interactions. A declarative language describes how to format the elements of a document, but not how to express or process those descriptions. A parser is software that examines text in a document and separates elements. HTML evolves. Early in the development of HTML, presentation was distinct from events and data processing. In later versions of HTML, particularly in HTML5, the distinctions have started to blur. Markup of events and data has simplified to enable web browsers to display HTML documents as the web developer intends. HTML focuses on presentation, the user experience, and document structure over other types of processing. Presentation is about the user's experiences on a website, including how browsers present text and interactions. In later versions of HTML, the markup language was updated to be more compatible with different browsers and more accessible for the visually impaired. An example is the M tag, which HTML and HTML-based markup languages use to emphasize text. Earlier versions of HTML relied on the I tag for italicized text and the B tag for bold text. While those tags are still used, web developers prefer the M tag for compatibility and accessibility. The tag signifies that the user should experience the text in the M element as emphasized relative to other text surrounding it. And HTML5 improves how browsers present information to users. For example, this expression emphasizes the text, "It was shocking." It was shocking. So how is this emphasized text displayed on a website? Depending on the browser, some users might view this as italicized text, and others might view it as bold text. And visually impaired users might experience the emphasis differently depending on what accessibility tools they use to browse the page. HTML has evolved to give developers the capability to create documents that are compatible across many different browsers and devices, while providing the structure that ensures that documents are presented as developers intended. About this module. Module 3. HTML5. The evolution of hypertext. Introduction. In this module, you will learn about the improvements that HTML5 brought to HTML document structure, data management, and interactivity for users. You'll also learn about the importance of browsers supporting HTML5. Learning objectives. After completing this module, you should be able to identify improvements HTML5 introduced to web development and users. Recognize the need for browsers to support HTML5. Big changes with HTML5. When you browse a website today, interacting with items and data on web pages seem natural and commonplace. Did you know that HTML5 made all this possible? Prior to HTML5, web developers had to rely on programs external to the browser to support animation and interactivity. Consider the following example. Suppose you use a task manager application to organize your school or project work. You can seamlessly interact with your data. For instance, you can use the drag and drop feature to move tasks around the page. Automatically save any updates to the server, such as if you change the date for a task. Add items like images and videos to your tasks and even edit them on the page. With the development of this fifth version of HTML, the language saw a dramatic improvement in how users interact with items and data on web pages, making some other programming languages like Flash obsolete. Once one of the most popular programming languages, Flash was the primary way web developers enabled experiences like video and audio to make web pages behave more like native applications. But Flash had some challenges. It wasn't mobile-friendly. It presented security challenges. Users had to download and install an application for their browser before a web page used it. HTML5 was developed to address limitations of using applications like Flash. It put the power of interactivity in the browser. To support the interactivity, HTML5 required JavaScript and cascading style sheets, CSS. While HTML5 looks similar to previous versions of HTML, improvements to document structure and tags allow more interactivity in web browsers. Here's an example of some HTML5 tags to show you how they differ from HTML tags that you've learned about. It's valuable to know about the differences between HTML and HTML5. What does HTML5 offer web developers and ultimately users? General improvements. First, HTML5 introduces more tags to describe how a document is laid out in the document structure and semantic structure. For example, a tag is semantic if the name clearly describes how it functions on the web page. Prior versions of HTML supported the OR division tag. A division might mean a lot of different things. It might mean a section of a page or a section of text like a paragraph. HTML5 introduced the and tags, among others. These tags more clearly describe how a document is laid out. Here are other general improvements HTML5 introduced. Semantic tags describe exactly what they are designed to contain. Pages are ready to use, and the overall experience is improved. HTML tags focus on the structure and content and allow other programming languages like CSS to manage graphic and layout elements. Separate networks are able to communicate through secure tunnels. Data and connectivity. In previous versions of HTML, handling data involved users submitting changes manually and refreshing pages to access the latest updates. On today's desktop applications, users can set up autosave, a feature that automatically saves changes to data without users having to manually select the Save button. HTML5 brought this functionality to the web. HTML5 supports basic data handling and improves how websites manage data. However, many web developers rely on frameworks for robust data handling. A framework is a set of tools that heavily uses a scripting language like JavaScript to manage data handling. These frameworks are built on the foundation that HTML5 provides. Here are some examples of open-source frameworks. Meta's React. Evan Vue.js. Interactivity. Perhaps the most interesting parts of the HTML5 specification for users, and fun for web developers, are the changes to interactions. HTML5 interactions can be striking and robust. With HTML5, graphics and video can be added without installing third-party plugins. HTML5 also enables web developers to use geolocation APIs, which can incorporate smartphone location capabilities into mobile cloud services and applications. Web applications. HTML5 ushered in the age of the web app. A web app is an application accessed using a browser that can be as robust and feature-rich as desktop applications. Many popular applications are browser-only web apps. While HTML5 has offered many improvements to how users interact with websites, browsers also need to be designed to support HTML5. Browser support for HTML5. Browsers must support HTML5 for developers and users to benefit from the specification. You'll recall that the HTML5 specification defines what HTML should support. It's up to browser manufacturers to implement that support. The HTML5 specification is broad and continually updated, so how a browser supports HTML5 varies. Browsers play an important role by utilizing the improved capabilities of HTML5. Browsers are continually changing, and the HTML specification is undergoing revision. Because of this, developers have created websites to test their sites in various configurations. As a web developer, you must stay up to date on industry news and the latest developments regarding HTML and browser support. It takes regular diligence to stay current, and you should consider this a part of your job as a web developer. About this module. Module 4. Function of CSS, styling web pages. Introduction. In this module, you will learn about style sheet languages and the type of styling language built from the HTML specification. In addition, you'll explore the history and function of cascading style sheets, CSS. Learning objectives. After completing this module, you should be able to describe the history of cascading style sheets, CSS. Summarize what a style sheet language is. Explain cascading style sheets. Describe the function of CSS styles. History of cascading style sheets, CSS. Did you know the first HTML documents were just text with many links to demonstrate the technology? As web technology advanced, engineers made it easier for web developers to make pages more dynamic. The appearance of the elements of a web page is called styling. Many of the descriptions in this module will use the language of the cited. But it's important to remember that the dynamic nature of styling a web page should be accessible by anyone. Styling is ultimately about the web page experience and not only how it looks. Web developers keep website styling a priority to ensure a dynamic page is dynamic for everyone. Here's a brief history about cascading style sheets, CSS, for web pages so you're aware of how it all began. Originally, HTML's power was in its ability to link documents. HTML focused on information. But as the development of HTML grew, developers saw the power of presentation in HTML, and the need to improve managing how to apply style to HTML grew. Early in the development of the web, some browser developers built styling languages into the browsers themselves. But the need for a standard style sheet language became apparent as multiple implementations became difficult to manage for web developers. CSS development coincided with the development of HTML and the World Wide Web. Hakan William proposed the original idea for CSS in 1994 while working with Tim Berners-Lee, the originator of HTML and the World Wide Web. Even though HTML was focused on information, the way that information was presented was important. CSS was standardized as the style sheet language that web developers used because developers understood the importance of presentation but needed a better way to manage styling HTML. They also had many versions of style sheet languages that became difficult to manage. Like HTML, CSS is a declarative language. It doesn't describe how a browser should render a style. It just describes the rules that browsers need to support. If CSS declares that an element should be bold, the browser must support the declaration to comply with the standard. How the browser supports it is up to the browser's developer. But the adoption of the CSS standard by browsers such as Netscape's Navigator and Microsoft's Internet Explorer helped make CSS the style sheet language of web developers. Now you know a bit about why and how the CSS language was created, but what exactly is styling? Formatting elements with style. Think for a moment about a bicycle. All bicycles have two tires supported by a frame, pedals, gears, and handlebars. If you were shopping for a bike, you might choose a specific frame color, bike height, handlebar style, or mountain biking tires versus street tires. These are all examples of your bike's attributes. Similarly, HTML element tags can have attributes. Attributes provide additional data that tell HTML browsers how the user will experience elements. A common attribute for many elements is the style attribute. By using the style attribute, you can fine-tune how elements appear. For example, you might have text that you want to bold, and you can use the strong tag like this. My bold text. The strong tag makes the text appear bolded. But what if you wanted to make that bold text also appear dark gray? Using a style attribute can help. The following HTML snippet will make the text bold and gray. My bold text in the example above, you'll notice that the attribute is nested in the opening tag for the element and uses the style equals construction. When web developers put attributes within element tags, they create an inline style. Inline styling got its name because the styles are contained directly in the line of HTML. This doesn't appear to be much of a language, does it? Well, there is a type of styling language that is built from the HTML specification. This language is called Cascading Style Sheets, CSS. What are style sheets? While you can put styles inline in the HTML elements, doing so can become very hard to manage the more style you add. Suppose you want many features to have similar styles. Using inline styles, you'd have to apply the style attribute to every element individually. Then, if you decide to change the style, you must change every element. A style sheet is a collection of styles. Developers created cascading style sheets to address the challenges with styling web pages. The cascade of CSS. Say you are developing a report on why you love your favorite sports team. Your report will contain headings, subheadings, and the text of your report. Within that text, you also need to add charts supporting your claims, some images of great players on the team, and links to your sources. Each of these pieces is a single element and a separate type of element. But when you create your report, you might nest images or charts within your text. And you might nest source links within your images or charts. In HTML, developers can also put elements within one another. Consider the following code. In this example, the developer wrapped the opening and closing tags within an opening and closing tag. The browser would place the image within a paragraph. If you were building your report as a web page, you might use similar code to place an image of your favorite player within a paragraph of text about why you like them. Web development professionals consider these elements parent elements and child elements. A parent element wraps around another element. One or more elements wrap a child element. In the previous code example, the element is the parent of the element, which is the child. This is important to understand to make sense of the cascading feature of cascading style sheets. Styles cascade in that child elements get the style of parent elements unless they're overridden. Web developers can override a style if the child element implements the same style as the parent with a different value. Now say that you want to offset your image on the page from the text by another 10px. A web developer might do this with the following code. Now, because the child element has the same style as the parent element, margin left, but the values are different, the parent element's style is overridden. In this example, the parent element will be indented by 10 pixels, but the child element will indent the image 20 pixels from the left of the page. Take a moment to check your knowledge about how styles cascade. So far, you've learned that web developers can use class and ID attributes to define specific styles and how those styles cascade from parent elements to child elements. Next, you'll explore details of CSS syntax and how CSS functions apply style to HTML. Using CSS syntax. Syntax is the vocabulary of a given software language. It refers to the terms and construction used to build the individual lines of the language and how each line works with other lines in the programming language. It's similar to syntax in any natural language like English or Hindi. CSS syntax is broad, and you can build many powerful style elements with the language. When creating a style element in CSS, you can build a class selector or an ID selector. Class selector. You build a class style when you want a given style to apply to many HTML elements in a document. You build an ID style when you want that style to apply to just one HTML element. You also can use HTML element names, such as or, as selectors. For example, suppose you want a style to apply to every paragraph element in your HTML document. You would create either a style with a class selector or HTML element selector so you can build the style once, and every paragraph element will get that style. Now, you won't have to apply the style to every paragraph element in the HTML document. And, if you want to change the style, you make the change to the style sheet, and all the paragraph elements will get the change. ID selector. If you have a particular element in your HTML document, say a section element, that you want to have a unique style, you will use an ID selector on that element. For example, suppose you have a section that you want bolded and in italics because it contains a legal disclaimer that you want to ensure everyone reads. You can create an ID selector and use that style just for that section. When creating a class selector, you use a dot or period on your keyboard. In CSS, the dot or period symbol designates a class style. It is placed before the style name. Class selector. When creating a class selector, you use a dot or period on your keyboard. In CSS, the dot or period symbol designates a class style. It is placed before the style name. ID selector. An ID selector is designated by a pound symbol or hash mark. The hash or pound symbol designates an ID style. It is placed before the style name. A style in a style sheet has the following three basic elements. Selector. The selector is either an HTML element, a dot for classes, or a hash symbol for IDs. Node name. Assigning a name to the style will help you understand what the style does. The name cannot have spaces. A best practice is to use camel casing for CSS style names. Camel casing uses a lowercase letter for the first word and an uppercase letter for each following word. This is an example of camel casing, minustil. Declaration block. Each style element will have one or more declaration blocks. These include styles surrounded by curly braces. Styles might include font weight and font color. The following image illustrates the basic elements of a style in a style sheet. The dot acts as the selector indicator. The class name bold gray text represents the node name. The open and close brackets are the curly braces enclosing a declaration block. Inside the block, font weight bold, and color, gray, each constitute a style declaration. Within a declaration, words like font weight and color represent the property. The corresponding settings like bold and gray represent the value. CSS styles can add more dynamic functions and make a website more interesting. Using styles, web developers can fine-tune how elements appear and create a better web page experience for everyone. About this module. Module 5. Function of JavaScript, Interaction. Introduction. In this module, you will learn about scripting languages and the ways they are different from compiled languages. You will also understand how a specific scripting language, JavaScript, was created and how it evolved to make web pages dynamic and interactive. Finally, you will understand the ways JavaScript interacts with CSS and HTML. Learning objectives. After completing this module, you should be able to summarize what a scripting language is. Describe the history of JavaScript. Explain what JavaScript does. Identify the ways JavaScript works with CSS and HTML. What is a scripting language? Early on, web pages contained text with hyperlinks. Today's web pages are filled with functionality that lets you do everything from banking to creating art. As you've learned, HTML and CSS mainly focus on the page's structure and how the content is presented to the user. While there are some action-oriented elements to HTML, such as hyperlinks, to create web pages that have interactions, you need to use a scripting language. Some examples of interactions are playing videos, doing drag-and-drop activities, and drawing. Forms that include drop-down menus, fields that look up data, and a spell checker are all examples of interactions. Web developers use HTML5, CSS, and a scripting language to build robust interactions. When you think of the word script, the idea of a rehearsed set of lines in a play or movie might come to mind. That's what early programming scripts were, a rehearsed set of lines, and why they were used to automate tasks. For example, a developer would use a script to run a program each evening to move data from a database to a backup instead of moving data one file at a time. Unlike a compiled language, a scripting language is human-readable, both when it's written and when the browser reads it. A compiled language is not human-readable when it's made ready for the computer. It's compiled into machine code that only the computer can understand. Scripting languages are in the family of interpreted languages. Interpreted languages need an interpreter, which is a piece of software that reads each line of code independently and executes the code line by line. Developers originally created scripting languages to execute small tasks quickly. In fact, in the early days of computing, scripting languages were the only programming languages. Today's scripting languages are full-fledged programming languages, and they're very powerful. When it comes to the web, developers use JavaScript more than any other scripting language. According to Stack Overflow's 2022 survey of developers, JavaScript is used by the majority of developers at 65.36%. This beats all compiled languages and even HTML and CSS, which come in at number 2 in the survey. Other common languages are TypeScript, Python, and PHP. 2022 marks JavaScript's 10th year in a row as the most commonly used programming language. Source: 2022 Developer Survey, opens in a new tab, Stack Overflow, 2022. Here are more ways that scripting and compiled languages are different. Speaking the language. Scripting languages are interpreted right when the computer needs them. This means the code the developer writes is the code the computer uses. Compiled languages must be translated into the language the computer understands before programs can be used. Ease of use. If a change needs to be made to code written in a scripting language, a web developer can open the code file, make the change, and upload it to the web server. Making quick changes to compiled code is more difficult because it needs to be translated before it can be used. Fast processing time. Scripting languages are interpreted when the computer reads them. This means they are translated from human-readable code to code the computer understands when the program is run. This processing time tends to make scripts slower than compiled code. Compiled languages are faster for the computer to process because they're already in the language the computer understands. History of JavaScript. The following events will help you learn about how JavaScript has evolved over the years. Inception. Like CSS, JavaScript was created in the early days of the World Wide Web to address a very specific need. Early HTML pages were static because they focused on presentation. Developers wanted a way for users to be able to interact with the elements on a page. Brendan Eich, a software engineer at Netscape, a manufacturer of one of the first web browsers, helped create JavaScript to provide this ability to make web pages dynamic. Standardization. As JavaScript became more popular, Netscape decided to standardize it. A standard sets the rules and the grammar that users of the language should follow. They submitted the language to the European Computer Manufacturers Association, ECMA, for standardization. ECMA manages the standard for JavaScript, and the generic, standardized form of JavaScript is called ECMAScript. Evolution. JavaScript has evolved tremendously over the years. Due to the need for backward compatibility, the language has evolved to include many ways to do the same. Often in technology, developers find easier ways of doing certain tasks. Languages are known to be backward compatible when they support new and old ways of doing things. You might have heard of the programming language called Java. Java is a compiled language developed by Sun Microsystems. JavaScript and Java have very little in common, and the similarity in their names causes confusion. As the story goes, the name JavaScript was given to this new scripting language mainly as a marketing tactic to capitalize on the popularity of the Java programming language at the time. The fact is that the two languages are not related. Over time, some developers also preferred to work in an object-oriented language. An object-oriented language can create entities in the code that can persist or be modified as they are used in other parts of the program. This creates a lot of flexibility and opportunities for code reuse. JavaScript is not strictly object-oriented. For this reason, Microsoft developed TypeScript, a programming language that transpiles to JavaScript. A transpiler converts one scripting language into another. When a developer writes TypeScript, a processing script turns it into JavaScript before it is published. What does JavaScript do? JavaScript is likely behind the interaction when you click a button or use a drop-down menu on the web. Browsers implement an interpreter that reads JavaScript and performs actions based on the script. Like CSS, developers can place JavaScript directly in an HTML document or a separate file so all web pages can use it. Developers often use JavaScript code to respond to an event. An event is something that happens on a web page. Here's how it works. You initiate an event when you click a button or drag a photo on a web page. HTML elements, such as a button element, have event listeners. Event listeners receive instructions from an interaction on a web page. When they get those instructions, then they can carry out the specific tasks. In programming languages, these tasks are called event handlers. Event handlers on the web are writing in JavaScript. Here is an example of JavaScript in a button interaction in an HTML code snippet. A code snippet is a section of code that you typically use for sharing and examples. It doesn't show the entire code that a web page needs to run properly. Notice that the event listener waits for the learner to select the button. When the learner selects the button, the event handler executes a script to show an alert. This animation shows the flow of event listeners, events, and event handlers and how JavaScript handles events. The animation shows the following HTML, which is for a button with an onClick event pointing to a JavaScript function called sayHello. Click the corresponding JavaScript is placed within an HTML script element and might look something like this. Say hello. Alert, hi there. In this example, the developer would put the script section in the header section of the web page, and the onClick event would call the sayHello function when the user clicks the button. When the JavaScript runs, a little box appears on the screen that reads, "Hi there." How does JavaScript interact with CSS and HTML? JavaScript is powerful, so developers not only use it for events but also to manage data and even create HTML and CSS dynamically based on certain conditions. As in the previous code snippet example, developers use JavaScript in conjunction with HTML to extend its power. Without JavaScript, and other scripting languages like it, users were unable to do many things that seem commonplace today like uploading and viewing photos, sending chat messages, or even watching videos. Web developers use JavaScript in conjunction with CSS and HTML to manage data and provide feedback to users. For example, JavaScript has the ability to find CSS selectors on a page and use those selectors to find specific fields that you might want to modify based on what the user does. Suppose you build a form with a section that uses CSS ID selectors. This code snippet is a simple form that asks the user for their first name and last name. First name last name. A web developer can write JavaScript code and use a function called querySelector to find the HTML element with the ID selector first name. The following code snippet shows the command in JavaScript. Document.querySelector, number first name. This line of code will scan the HTML document for an element with the ID attribute of first name. Once the code finds the element, the developer can evaluate the value of the field. Suppose the developer runs that command after the user selects the submit button on the form and determines that the first name field was not filled in. They can then provide a message stating that the user must fill in the field to submit the form. Take a moment to check your knowledge about the features that HTML, CSS, and JavaScript can support. About this module. Module 6. From Requirements to Launch. Introduction. In this module, you will learn about the Software Development Lifecycle, SDLC, and explore the 6 common phases related to web development. You'll also learn about the differences between the waterfall and agile approaches to development. Finally, you'll get a quick overview of the Scrum framework. Learning objectives. After completing this module, you should be able to identify common phases in the software development lifecycle, SDLC. Compare waterfall and agile approaches to development. Highlight the components of the Scrum framework. Software Development Lifecycle, SDLC. When Tom Kilburn wrote the first piece of software in 1948, it contained only 17 instructions and took 52 minutes to compute. But from the beginning, computers and their programs have been complex systems. The first mainframe computers filled entire rooms. Organizations needed a way to manage large software projects running on those computers. The system's development lifecycle was born in the 1960s, and variations of the framework evolved over time into the Software Development Lifecycle, SDLC. The SDLC is a framework for systematically building high-quality software and websites that meet user requirements. The SDLC provides a way to plan large projects and offers a set of standard steps and deliverables for each project. While there are many variations of the SDLC, a few common phases exist. 1. Planning. 2. Design. 3. Development. 4. Testing. 5. Launch. 6. Maintenance. Review these phases to learn how they relate to web development. Planning. The planning phase of the SDLC aims to gather requirements from various stakeholders and analyze what is achievable. In web development, the planning stage defines the goals and purpose of the website. In this phase, the team might also determine the website's audience and start to plan what types of content will be on the site. Design. When you hear design, you might think of a website's visual layout, colors, and brand elements. While the team focuses on these things during the design phase, they also design all other aspects of the website to meet user requirements. The team will design the website's sitemap, navigation structure, and information architecture. Sitemap. A sitemap is a hierarchical model of all pages and content of a website that inform the navigation structure. The following abstract diagram illustrates this hierarchical relationship. Navigation structure. The navigation structure outlines how the different pages on a site are structured and define how they are connected to one another. Navigation structure is often used in a website as a navigation menu. The following is an example of the navigation structure for a museum website, and you can see how it informs the navigation menu. Information architecture. The information architecture is a method for organizing, structuring, and labeling content so users can easily find information and complete tasks. The following diagram illustrates the information architecture for a museum website. The team is also responsible for content mapping and planning media elements to support the text. Development. During this phase, web developers use the requirements, design wireframes, and other deliverables from the design phase to build the website using web development languages such as HTML, CSS, and JavaScript. Testing. During this phase, web developers, quality assurance, QA, testers, and other members of the team will test the website for usability, accessibility, and more. This phase aims to ensure that the website works according to the requirements gathered during the planning phase. Launch. During this phase, the team will publish the files to the server and launch the website. Maintenance. During this phase, the team will review user feedback, customer support issues, and other technology advances, and then update the website. The team might also update content or media during this phase to keep the website fresh for users. You just got an overview of the 6 common phases you can expect in a web development project, based on the Software Development Lifecycle, SDLC. Waterfall versus Agile approach to development. Initially, each phase of the SDLC followed a step-by-step method from planning to maintenance. Developers refer to this approach to the SDLC as the waterfall approach because it flows from one phase to the next phase in a downward fashion. The sequential steps of the project lifecycle are planning, design, development, testing, launch, and maintenance. There are benefits to this approach for developing software, however, there are some disadvantages, including long cycle times. Since each phase of the approach might take any amount of time, the entire process might take months, if not years, to complete. By the time projects were complete, the product they had developed might be outdated. Less user interaction. With the waterfall approach, users are brought in only at the beginning of the planning phase to gather requirements and at the end of the cycle. This means that users' needs are only determined at the beginning of the project, and if their needs change throughout the project's life cycle, those needs will not be addressed. Postpones testing until the end. Because testing is at the end of the cycle, the team might not recognize issues until much work has already been completed. Depending on the size of the issues, solutions might be costly and delay the project's launch. Given these challenges, what do you do? Well, in the early 2000s, a few developers came together to address some of these issues with the waterfall approach. A few variations to waterfall had already been developed, but this group wanted a new approach that allowed organizations to speed up development times. With the goal of faster development times in mind, these developers created the Manifesto for Agile Software Development, opens in a new tab, which laid out 4 key values. 1. Individuals and interactions over processes and tools. 2. Working software over comprehensive documentation. 3. Customer collaboration over contract negotiation. 4. Responding to change over following a plan. These 4 values led to the development of the Agile framework. Agile allows teams to deliver products in small increments, minimizing the disadvantages of the waterfall approach. Agile is inherently about these 4 values. Scrum framework. Organizations have adopted methodologies such as Scrum, an iterative approach to implementing Agile. Iterative means the process is repeated often and sometimes the same steps can be repeated several times. The Scrum framework is made up of Scrum teams that deliver work in sprints and participate in Scrum ceremonies. Following is a diagram of a typical Scrum framework in which teams work to deliver in short increments. Notice that the framework emphasizes a more iterative approach. Scrum teams. Development teams work in small teams to focus on developing a solution for one objective at a time. Sprints. Developers complete work in sprints. A sprint is a set period of time in which the team works on a specific, small set of work. The work goes through the entire development lifecycle from planning to launch. Before starting a sprint, the team conducts sprint planning to determine what work needs to be done and how long it will take. A sprint backlog captures work that needs to be completed but has not been started. The sprint concludes with a retrospective, which is a review of what worked during the sprint and what practices can be improved in the next sprint. Ceremonies. Teams participate in specific meetings, called ceremonies, such as sprint planning, daily scrum or stand-ups, sprint reviews or demos, and retrospectives. These ceremonies provide commitment from the team on what they will develop, early feedback on the product, and quick identification of issues that might arise. While Scrum and Agile are often thought of as the same, they are not. Agile is a set of values and principles. Scrum is one of many methods for implementing Agile principles. Much like waterfall, methods of implementing Agile have evolved, and new variations have been created over time. Kanban opens in a new tab, and Extreme Programming, XP, opens in a new tab, are a couple of examples. It's valuable for you to be aware of the different approaches that web development teams take for projects. Explore more. Check out the Agile Alliance, opens in a new tab, to learn more about the 12 principles of Agile, opens in a new tab, the Agile Manifesto, opens in a new tab, and the Basics of Agile, opens in a new tab. You've come so far and learned so much. You learned that developers create websites in different styles and layouts using markup languages. A thorough understanding of the different tools and languages, such as HTML, CSS, and JavaScript, is essential. You also explored how these tools evolved and improved over time and gained an understanding of the software development lifecycle. Now that you've completed this course, you should be able to identify the purpose of web browsers, describe markup languages and the challenges they can overcome, explain the structure, functions, and evolution of HTML, identify improvements that HTML5 introduced, explain the features and functions of CSS, explain the features and functions of JavaScript, identify the ways JavaScript interacts with CSS and HTML, identify phases in the software development lifecycle, SDLC. Differentiate between waterfall and agile approaches to development. Highlight the Scrum framework. Key points to remember. 1. The browser interprets HTML markup and reports using human-readable styles and formats when rendering an HTML document. 2. Markup is wrapping text with indicators that guide what should be done with that text. 3. Markups are text-based and include links to resources, making them easy to interpret and display. 4. A properly structured HTML document includes the HTML tag, the head section, and the body section. 5. HTML attributes are additional data a tag might need to provide the parser with enough information to create the formatting the element needs. 6. A semantic tag clearly describes what it does to the browser and the web developer. 7. Frameworks are tools that heavily use a scripting language like JavaScript to handle data. 8. Developers created the cascading style sheets, CSS, language to add styling to elements of the same class or ID without needing to style every element in an HTML document. 9. A style in a style sheet has 3 basic parts, a selector, a node name, and a declaration block. The declaration block has one or more styles that are made up of properties and values. 10. A primary feature of CSS is that child elements get the style of parent elements unless they're overridden. 11. CSS mainly focuses on website presentation, and the code can program the text, style, and function of the site. 12. JavaScript controls interactivity on a website, such as button clicking, pop-ups, and refreshing a web page. 13. JavaScript, HTML, and CSS all work together through code to display a web page and all its features. 14. The waterfall approach is a step-by-step action plan that flows downward like a waterfall. 15. The agile approach is iterative, meaning the process is repeated often and sometimes the same steps can be repeated several times. 16. Scrum is an iterative approach to implementing agile in which teams deliver work in sprints and participate in Scrum ceremonies.